Hey everybody, King here, and this lesson's on solving polynomial equations. I'm going to guide you through 3 examples of solving polynomial functions. 2 are going to be looking at the functions graphically and the equations, and 1 is going to be without the graph. This is what you've been waiting for. We are going to start analyzing polynomial functions. The whole reason we did so much work with factoring was so that we can do this. Okay, so the first example that we have is, locate all the x intercepts on the graph. So that's just looking at the picture itself, and let's see, you can see one at -3, see one at 4, and then that one looks like a little less than 1, but we're not sure, so we can't. That's not an integer. So we're gonna leave that alone and locate. Okay, so -3 and 4 are our 2 x intercepts that are integers. If x is -3, then x plus 3 is a factor, and if x equals 4, then x minus 4 is also a factor of this function. So we're going to do synthetic division with each of those integer intercepts to find the remaining factor. So let's set up a synthetic division problem with the original. Now at this point, it does not matter which factor you use to do your first step of synthetic division. I'm just going to choose a -3 because I wrote that first. So the 4 times -3 is -12. -7 plus -12 is -19. -3 times -19 is going to be positive 57. -45 plus 57 would be a positive 12. 12 times -3 is -36. That 0 remainder, very good, because it's a factor, so it should be a 0 remainder. And we can just leave these numbers right here and just move on to the next synthetic division, because this represents the polynomial 4x squared minus 19x plus 12, which would be the factor of this polynomial if we factored out x plus 3. But let's also factor out this x minus 4. Bring down the 4. 4 times 4 is 16. Add these two together, -3. -3 times 4 is -12. Add those together, 0. Booyah, grandma. Gives us the remaining factor of 4x minus 3. Okay, so let's rewrite the polynomial in factored form here. So we have x plus 3 times x minus 4 times 4x minus 3 equals 0. Step 4, set each factor equal to 0 and solve. Use other factoring methods or quadratic if needed. Well, we do not need the quadratic form, thankfully. We set this one equal to 0, x plus 3 equals 0. Subtract 3 on both sides, x would be -3, which we already knew that. Next factor, x minus 4, set that equal to 0 as well, and then solve for x. So x minus 4 equals 0. Add 4 to both sides. X is going to equal 4, which we already knew that as well. Just confirming. 4x minus 3 is the last factor. Set that equals 0. Add 3 on both sides. 4x equals 3. Divide by 4. Divide by 4. On the left side, we have x. On the right side, I have 3/4 there. It's kind of squished right over here. X is 3/4, which makes sense because we knew it was bigger than, looks like bigger than a half definitely, and less than 1. So I'll buy that. So we have our 3 intercepts. X is 3/4, x is 4, and x is -3. That's example 1. So if you want to pause here before you move on to the next one, that is perfectly fine. Always recommend a little break if you need it. We're going to move on to example 2. Same idea. different factors. So let's look at the graph. Looks like we have a x-intercept at -2 and 3. So x is -2 and x is 3. The x -2 is going to give us x plus 2 as a factor. X equal 3 is going to give us x minus 3 as a factor. We're going to set up the synthetic division. Same process here. 5, 1, -44. Writing down the coefficients of the polynomial in standard form. -28, +48. -2. Okay, bring down this 5. Start the synthetic division. 5 times -2 is -10. Add the 2 together. It's going to be -9. -9 times -2. I'm going kind of quick with this because this is stuff we've done in the past already, synthetic division. If you do need help with this, go back to a video on synthetic division or look up any other resource that I've pointed you to in the past with using how to do synthetic division. Add -44 and 18 together, you get 20 would be 24 plus 4, 28. So 26, 24 plus 2, -26. -2 times -26 is +52. Add those two together, you get 24. Multiply by -2, -48. Add those two together, you get 0. Good. That means we're doing our multiplication and additions correctly. Let's break down that synthetic division of x minus 3. Down to 5. 5 times 3 is 15. 15 plus -9 would be +6 times 3 is 18. Plus -26 would be -8. -8 times +3 would be -24. Add those together, 0. Good. Confirming that they are in fact factors. Rewrite the polynomial in factor form so far that we know it's 5x squared plus 6x minus 8 times our two factors, x plus 2 times x minus 3. Okay, I'm going to jump over here. We set each of these two factors equal to 0 first. X plus 2 equals 0. Subtract 2 on both sides, so we get x equal -2 for one of our intercepts. X minus 3 equal to 0. Add 3 to both sides, so we get x equals 3 for another one of our intercepts, confirming what we knew by looking at the graph. Now for this next one, we actually do need to use the quadratic formula unless this is factorable. Use another factoring method. Do a quick check here. 5 times 8 is negative 40. -40 and 6. Do I have two numbers that multiply to be -40 but add to be +6? Well, yes, I do. 10 and -4. So this is factorable. So 5x squared plus 6x minus 8 is factorable. I'll show it by the box method, which I used in class. I don't particularly like this method, but it's approachable by many students. So we'll go here, 5x squared -8. Let me write these two numbers in here, our 10 and our -4. So and then make sure it's x. So factor this way. The only thing factor between those two, greatest common factor between these two is x. The greatest common factor between these two, it would be a 2. Greatest common factor between these two would be a 5x. Greatest common factor between these two would be a negative 4. So that tells me that x plus 2 times 5x minus 4 are the factors of 5x squared plus 6x minus 8. We can check. Multiplying this out, x times 5x is 5x squared. X times negative 4 would be minus 4x plus 10x from the 2 times 5x minus 2 times negative 4 negative minus 8. And this is equal to that. So yeah, this checks. So these are the other two factors. If that's the case, we can set each of these two factors equal to 0. We already did the x plus 2 over here. That's a repeat factor, which makes sense because of how this kind of bounces off at this negative 2. We didn't get into that, but we will soon. What happens when you repeat a factor of a polynomial? This actually bounces off. So we set 5x minus 4 equal to 0. Add 4 to both sides. 5x equals 4. Divide by 5. We're solving for x, guys. Divide by 5 on both sides. X equals 4/5, which again is right below 1. So that looks like it makes sense as well. You need another break? Go ahead and take another break between this example, and we'll be right back. We're moving on to example 3, solved by factoring no graph given. At this point, I would move on to the third example, but we are already at over 11 minutes, and I'm going to get cut short because I don't pay for Screencast-O-Matic Pro. So I'm going to cut short, and I hope that you enjoyed this video.